This is the basic proof of concept here, including safeties. We have the voltage being measured through the CCS plug here. So once we get the DC energy coming out, this box will be measuring the voltage of the bike to make sure it doesn't go too low. If it gets too low, it will automatically turn the bike off. Moving on from there, we have our 12-volt battery, which is necessary to switch all of the switches. We're pumping that all into our 5 kilowatt inverter here. So this is pretty high density. More work we can do to get maybe double the power. For now, it's 5 kilowatts. We've also hooked it up to the beat light. So that way you can see every time the voltage is going to be measured, the beat light will flash before it measures, and then it will flash after the measurement is complete. To your average user, it'll just look like, oh, my bike is doing something, yay. But for people who know what they're looking at, that's the time when the high voltage contactor is going to be closed for measurement. Other than that, it will be open so that no high voltage exits the bike at all. Here we go. We're going to connect this. See, everything powers up. It just tested the voltage before it turned itself on. And then you should hear this thing kick into high gear. When it does that, it has sagged the bike too low. Okay, so the last startup that I did where you saw this light bulb not light up was because the bike is currently at a low state of charge. It's at 293 volts. With everything that we have going on and the capacitors charging up, it actually caused the safety protections to come in, and it said, nope, we're not gonna let you take AC out of the bike because the bike is too low. So what I've done is I've reflashed the board to allow a lower voltage for operation. We let it run down to 280 volts now, and I'm gonna demonstrate how everything turns on now. Also, different from the last time around, now the electric beat only comes on after voltage has been measured. That's done just to allow the time for the voltage divider to charge and then give its reading. There we go. We got power. And, yeah, full power. Wonderful.